Hello folks, my name is Alexei and welcome to the new series called Cookboot, dedicated to building a web service for managing cooking recipes. The motivation comes from me recently becoming a cook, well, kind of not a cook, trying to cook myself, and I ended up needing to store my recipes somewhere. And while I could use one of the tons of existing solutions, it's always fun to build something ourselves. Also, I'm going to start working with Python soon, and that brought the motivation both to use Python here and then to do this as a bigger kind of as a proper project overall. With this series, we are going to focus on the backend parts of the web service, mostly because this is just my domain and area of my interest. So while we are going to have some client side definitely at some point, the majority of this series will be focused on the backend systems. I'm also going to treat this like a really professional project because while there is always some desire to cut some corners and do something quick and hacky, in this case, one of my goals is to actually learn some proper Python development for bigger systems. I'm coming from languages like Java, C#, and Go, used in bigger environments to have bigger systems, and I'm quite interested in seeing how does my knowledge and experience transfers to the Python land and what things are already existing and available in Python, what things are done different, similar. That's the motivation to have this as a big, like not big, but a proper professional project, not just few hacky scripts connected together. I'm also going to show my tools and setup along the way. I know I'm not claiming that these are the best tools. It's just the stuff that I'm comfortable with. Would be super cool and interested to learn what are your tools used for the similar purposes. So please leave those in the comments. Really interested to learn from you. And also a small disclaimer that I'm not going to dive into the basics of the coding. So for people who don't know how to program in Python at all, it would be best first to watch some other videos, maybe go through some introductory course, because then other stuff will make much more sense to you. We are definitely going to discuss a lot of code through this series, but not the basic lines, not the variables or functions, this kind of stuff, more like intermediate level concepts and maybe advanced concepts along the way. As this is the first introductory video, we are going to do what I would always do first for any real project, and that is to do some design, some project design. And I typically start designing project with thinking about the use cases. What are the things that this project will do? What are some user requirements or user pains that this project will be able to deal with? And also, that also brings us to the question, who are our users, or in kind of more formal way, who are the actors in our system? And so in our case, the main two actors that we will be focusing on are a user, basic regular user, and an admin, which is actually also kind of a user with the main difference that they have different access scope, which means that, for example, probably an admin can access a recipe of any person, while the user can only access recipes of themselves. By the way, yeah, we are not going to build any kind of social network for now. So a user can store their recipes, see their recipes, and like for now there is no friends or discovery or this kind of stuff. The use cases I'm actually bringing kind of my use cases. So again, part of the motivation is actually to build some nice, useful tool for myself. And this combines in two types of use cases. First of all, some typical crude use cases. So use cases related to create a recipe, read or view a recipe, update a recipe, and delete a recipe. Very typical operations for any resource, for almost any kind of service. In addition, there is a quirk here, and this is where you see here of the error going on the side. Regarding viewing the recipes, I want to specifically highlight mobile device versus kind of any device here, because while most of this will probably happen just in web, we're not going to build any Android or iOS apps for now, so it will be web-based. I really use a lot chats and chatbots in my day-to-day work, and so for me it would be way more comfortable actually when I'm going to cook. For me it would be way more comfortable to see the specific recipe that I'm cooking now on my mobile device, on a phone or a tablet. And as we are not building a mobile app, and I find it not, especially on the phone, using browser is not as nice for me. Like a lot of screen estate is taken by the top, like by the header and the footer bars. I really prefer to use chats for that. So I want to have a chat bot as one of the entry points to our system that at least can handle viewing of recipes or a specific recipe. And that's why here on viewing recipes, we have two separate cases. One, when we are cooking and we want to view something on the mobile device, probably from a chatbot. And another one is kind of anytime, and then it should work in the web on any device. Deleting recipe, kind of straightforward. There are three use cases which go beyond the crude operations. And this is about tracking how many times I've cooked a recipe, so doing some statistics. And also, in addition to that, maybe, marking how I liked the recipe. And then something a bit more unique and specific to recipes is recipe variations. So probably if you cook, you probably do it as well, is that after you cook maybe a few times something with the recipe, you start tweaking it. Sometimes you tweak it from the get-go and you add or remove some ingredients or change the proportions. And it would be really cool to track these variations. And in addition, it would be really nice to be able to rate those variations, because then after I cook something for 10 times in 10 variations, I want to record those variations. I want to mark how I like them so that later when I come back to this recipe, after half a year, I can easily see which variation I like the most and I could pick up that one. So these three are a bit, they go beyond the CRUD, and they definitely will make our system design also a bit more interesting. It's important when doing design to explicitly highlight some things which could be very obvious use cases, but that are not. And as I mentioned, in my case, for example, we are, at least for now, we are not building a social network. While again, it sounds in the current age, it sounds super easy and super understanding if from my service I can share a recipe with a friend, or maybe I can share the results. So I've cooked something and maybe I can discover favorite recipes of my friends. This is all sounds nice and interesting. Maybe at some point we are going to go into it, but at least for this initial design, this is out of scope explicitly. Now, let's look into some basic design. So let's start with the four use cases, with those crude use cases, which are the most typical ones highlighted here in green. And then let's take probably the most basic of them, when user wants to view a specific recipe so they know which one they want to view. And then a very simplistic diagram of how this might look like is as follows. On the left, we have our user, basically some client-side application. It issues a GET request with a specific recipe ID to the web server. The server looks in the DB, it gets the result, well, if it exists, this recipe, and sends back to the user. Super simple, super plain, and that's what we are going to focus on initially building in Python. We could call the end here, but what I found useful is when you do some design is to look a bit beyond your initial plans. It's really important to plan architecture extensible, so with extensibility in mind. And I find particularly helpful myself to see a bit how this service can evolve in future, to just have a bit of that idea in my head. For example, here, there are some use cases like the chatbot that I mentioned, right, which currently here are not present. And also, what if the service becomes more popular and starts getting more load, how that might change. So let's just look a bit more how this diagram could potentially change in future. So here at the top, we have again the very basic first version. At the bottom, we have a version which includes the chatbot option to view the recipes. So if we can view the recipe not just from our website, but also from some chatbot, I use a lot Telegram, but you may use tons of other chats. Most of them these days have bots. Now it becomes reasonable to have separate chunk which interacts with the user, and then if it's a REST API, if it's a HTTP, HTTPS, it's one thing. If we are talking about chatbots, then you need to have a different front for this chatbot, which will use whatever the chatbot protocol is there to interact with the chat application. And then separately of that, it makes sense to have the core logic residing in a separate deployable, in a separate chunk called here backend server. This means that even if we have different fronts to interacting to different clients, we will need to write the logic only once. It will live in a single place, and the behavior between these two clients will then also stay consistent. This will bring us to having this edge of our network. So these web server, gateway, and the bot server, they become kind of like an edge of our network. And the logic will reside in this really backend server. And then, of course, like between those two, we can have some internal API where both can interact with the backend server to get a recipe. We still want this basic use case of asking for a recipe. And nothing changes in this case for our DB. It just stays there. The interaction there is the same. This is already nice and good. This is already suggests us, like kind of reminds us that we should decouple our logic, the real application logic, from the routing, from the handling user requests, because in the web version versus chatbot version, those requests will be different and they might require some different handling steps. Another thing we could think about is a bit what happens if the load increases in this. And this, again, at the top we have what we just previously discussed with the separate clients for separate front ends. It's backend front end for different clients. So by the way, I've seen a lot of confusion around in the industry between the names of client side, server side, front end, and backend. What I'm calling here, let's actually scroll back to this. What I'm calling here on the left is the client side. So in this case, this can be a web application in the browser. It can be an application on a mobile phone. Client side means it lives on the client device. That's why I prefer this over the front end, because front end, any system can have a front. And actually, most of systems will have some kind of a front. While client side is very clearly what lives on the client, the green web server and the blue ReceiveDB, both of these are server side. So they together form a server side. And then if we start looking in our second picture, the server side can become, as it becomes more complex, it actually gets the front part and the back part. So these web gateway server and the bot server, I typically think of them as the front end of our server side. So they live on the server side, but they are the front end because they are the end that the clients interact with. And then the server, which has the logic, it lives behind the front. You could say it's in the middle, but for now we can just call it back end. And this would be really on the back end of our system together with the database. So this backend logic server and the recipe DB, those together form a backend of our server side. And so now going even forward, as the load increases, we might want to switch and put a queue here between our front end, between our edge of our server system and the backend chunk. The benefits of the queue are that one, it helps to very easily kind of naturally deal with any load fluctuations. So if at some point you get more requests than expected, queue can kind of allow an easy mechanism to gracefully handle this. It will not magically become faster, but it will be just a graceful handling of this situation. And then typically with the queue, what goes very well is a pool of workers. And so we transfer our backend server from like to be explicitly worker pool, not stated here, but it's very beneficial when these are stateless, which means they don't store in themselves any special data in their memory. Everything that they need to handle a request is stored somewhere else in the database, comes together with the request. Maybe there is, I don't know, if we need caching, maybe there will be some other caching system, but not on the machine where the worker runs, like not in the worker itself. The worker's memory is used only to handle specifically the request, and if the worker dies and the new one comes, they're kind of identical. And this together with a queue, especially if it's a persistent queue, so the queue which can, which lives not only in memory but is persisted somewhere in disk, this combination provides a very nice, reliable mechanism to work with. Because if for the worker, during processing some request, the worker crashes for any reason, then the main thing is that just the message from the queue is not acknowledged, so it comes back to the queue, and the next worker can just pick it up and execute. It's really important to handle here idempotency properly so that the results, so it cannot be that the worker actually finished doing stuff, crashed afterwards, after publishing a result. And then because it crashed, it kind of not acknowledged, so it necked the message. And then a different worker can pick up this message not knowing that the result actually was already sent to the reply. So there are some small things, like not small, it's important to pay here some attention and make sure this is done properly to handle idempotency. But other than that, this is a very nice setup, and typically it's used with two queues. So there is like some queue, in this case it's task, but it could be called something different. And then a reply to, and the name typically is like this, which is used later to kind of send the result back. This is where we will kind of stop our design wandering for now. Again, we're not going to implement this from the get-go. Premature optimization is a good way to make sure the project never actually gets implemented, never see the light of the day. We are going to implement the most basic version, but understanding a bit this in mind, what could await us in future, can help us when we will be building the software architecture. Also, kind of an honorable mention that on this, a whole host of topics is not mentioned: authentication, authorization, rate limiting, input sanitization, caching, ton of stuff. A lot of this we will need to have. A lot of this we'll need to have from the very basic version. A lot of this later will migrate to our edge servers, to our edge boxes. And then maybe in future, if they become really big, they will be deserving their own small service, their own deployable, like authentication, for example. But this is really far ahead. I just want to let you know that, yes, of course, all of these are also on my mind, but we are not going to focus on them initially. And with this, the last thing to talk today about is to bring just a bit more details to the technologies we're going to use. So again, we will start with this most basic architecture. On the client side, I'm probably going to use React. I'm not sure yet. As I mentioned, my expertise lies more on the server side. I've heard a lot about React being the most popular, so that's probably what I will be using. Maybe we will see how ChatGPT can help me or cannot with the React. We'll have to see that. On the web server, on the server side, we will start with UVcorn or maybe Gunicorn, I think it's spelled like this, plus UVcorn, which are some solutions for running the web server itself on the machine. I will have to Google a bit more to check if I want to switch this to Apache or not, but at least we will definitely start with UVcorn as being a very popular in the Python community. We also are going to use Falcon ASGI framework to bind the web server, the UV coin, and our custom logic to handle the requests. And of course, like it has to be ASGI to allow asynchronous programming and behavior. We are also going to use SQL Alchemy to manage connection and interactions with the database. And we are going to use hexagonal architecture principles while building our server. These principles I find very useful, resulting in a very clean and nice architecture with a good separation of concerns, extensibility, and quite loose coupling. So we'll have to see how much coming from the Java world where there is a lot of stuff for hexagonal architecture implementation, I still have to explore what exists already in the Python land, but even if nothing, this architecture, most of all, it's a set of principles. So it's more important than frameworks here is to follow some specific steps around how to structure the context of each part of the application, where to draw boundaries, and how to handle dependencies. On the database side, I'm going to use something SQL, probably starting with MySQL and then seeing maybe swapping this later for a different flavor. Should not be that impactful. And that would be it. I hope it's interesting for you, and I see you in the next one. Have a good day and ciao.